Yeah, hi guys, good afternoon. Welcome to the third uh, video lecture. This session is on the lab program 8. So we have already completed till lab program 7 in part A. Now today I'm going to explain you the lab program 8. So the lab program 8 question is like this. Write a program to count the number of ones and zeros in two consecutive memory location. You have to write an ARM assembly level program in order to count the number of zeros and ones in the two consecutive memory locations. Because any thing, when you write, it is ultimately represented in terms of zeros and ones. Now you're going to define two 32-bit numbers in two consecutive memory locations and going to count the number of zeros and number of ones present in that. So this is what the lab program is, and this is the 8th lab program in part A, that is the software program. Now so description on this lab program. Here we consider two 32-bit numbers stored in the consecutive memory locations and count the number of zeros and ones. So these are the two consecutive 32-bit numbers which we are considering, and we go for counting the number of zeros and ones in these two 32-bit numbers. Now let me explain brief on these two 32-bit numbers. The first number is 111181 and the second number is AA55. So each one is a 32-bit number. Now when this hexadecimal number, the first number which I showed you in the previous slide, in binary it is something like this. Now 00, this one is represented by 0001, and this one is represented by 0001, and this one again 0001, like this. Now number of ones in this binary representation of this hexadecimal number, which it is a 32-bit number, is number of ones is 8. You can count 1 2 3 4 5 6 7 8, and number of zeros is 24. 3 plus 3 6 9 plus 12 plus 3 15 plus 3 18 plus 3 21 plus 3 24. Now in this first number I have 8 ones and 24 zeros, and similarly the second number AA55 in binary representation it is like this. The binary equivalent of this hexadecimal number is this. It's a 32-bit number again. Now in this we have 16 ones and 16 zeros. You can count if you want, because we have equal number of A's and equal number of I's. 1 2 3 4 5. So this 10 10 is for this A. This 10 is for this A, and 1010 for the second A, and 0101 is for 5, and 0101 is for next 5. Now this is the 32-bit binary equivalent for this hexadecimal number. Now we have a number of ones 16 and number of zeros 16 in this. In total, if you count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 ones, and similarly the 16 zeros. Now the program which you write, it should go for counting the number of zeros here, total number of zeros here in this first number, and this total number of zeros in the second number. Now when I take the total number of ones in these two, in the first number I have 8 ones, in the second number I have 16 ones. 8 plus 16, that is 24, and hexadecimal equivalent for that is 18. And similarly, when I count the number of zeros in the first number and the second number, it is 24 plus 16, that is equal to 40, and I have total number of 40 zeros. Hexadecimal value is represented by 0x28. Now this is now we're going to write a program in order to do this. Now we were writing program to do this now. Now the concepts used here in order to count the number of zeros and ones simple, which I've already explained to you people when in the third chapter when we were discussing the instruction set of ARM processor. This is one major instruction that is used in order to count the number of zeros and ones, ROR, rotate right. Now rotate right, the pictorial representation this I've already shown you. It is something like this. What it will do, the rightmost bit from the number which you're shifting goes to the leftmost position, and the same thing is also going to the carry flag. Now we encache this feature in order to count the number of zeros and ones, and this is what we do rotate right. Every time we do the rotate right, the bit which goes from the right side goes to the carry flag, and the same is rotated back to this, and we're going to do this 32 times in order to check how many zeros and how many ones are there. Now BHI is one more instruction, that is branch on I, and this is the instruction which checks the carry flag is I or not. When you rotate right, if the carry flag is I, it is 1. If the carry flag is low, then it is 0. And accordingly we can go for counting the number of zeros and ones. So these are the two major instructions which we'll be using in our program. Now this is the program. We are into the program now. I'm starting explaining the program. Now before I start explaining the program, let me show you one thing. This is what the binary number for, decimal number, hexadecimal number. In binary it is something like this. Now when I rotate it for the first time, this one goes to the carry flag, and the same is rotated back and sent to the leftmost position. Now when I do that, this is what the answer I get. Now this is nothing but 8888. Now when I do one bit rotate right on 111, I get 888. Now and the when I rotate right, what goes to the carry flag is CF. Now and using BHI check whether it is carry flag is high or low. So BHI, since the carry flag is getting 1, it will be true, and I just increment the count related to ones. And similarly, if 0 goes to the carry flag, then BHI will be false. I'll be incrementing the count related to the zeros, number of zeros. And similarly, when I rotate it for the second time, so this is the number. When I rotate it for the second time, 0 goes to the carry flag, and the same 0 is put back here, and what I get is 444. You can observe this is 8 8 8 8 8, and similarly now this is 4 4 4 4 4. Like this it goes on. How many times you do this? You're going to do this for 32 times. Now we'll go back to the program. Yeah. Now here we are starting from here, from the start. Now area name I've given it as 190. Now R2 is the counter for counting the number of ones. I'm initializing it to 0, and R3 is the counter for counting the number of zeros. I'm initializing it to 0, and R7 counter to get the two words, because you're not counting the number of zeros and ones from one memory word. Now you're counting the number of zeros and ones from two memory words. Now this R7 is holding the number of consecutive memory location from where you're counting the number of zeros and ones. And now R6 is equal to value. Value is the memory location which is basically present inside the code region only, and holding those two memory addresses here. Value DCD, these are my two numbers, two consecutive memory locations. Now what R6 gets is the starting address of my value, and then I'm loading R1 with the 32, because I got to repeat this loop for 32 times, because to count the number of zeros and ones, I have to repeat it for 32 times, and I do it one word at a time. I'll take the first word, I'll count the number of zeros and ones there, and I'll take the second word and I'll count the number of zeros and ones again there. Now so R1 is initialized to 32, and now load the content pointed by R6 to the register R0. Now R0 will get 1111, our first number. R0 will get this number, and then R6 is incremented by 4, and it is pointing to the second number. Now after the first number is loaded to R0, you are going to do the rotate right by 1 bit. Rotate right on R0 by 1 bit, and after rotating by 1 bit, the rightmost bit goes to the carry flag, and the result is updated to R0. That's what when I do rotate right on 111, which is present inside the register R0, I get 888, and the rightmost bit goes, which is 1, it goes to the carry flag, and this R0 gets 888. Now after that, since you can observe in move yes, it affects all the conditional flags, and it is going to affect the carry flag. Carry flag will be changed to 1 if when we rotate, if the bit 1 goes to the carry flag. Now the 1 goes to the carry flag, BHI, this checks whether the carry flag is high. Now it is true, it goes to branches to ones. Here what I'm doing, and the register that was designated for counting the number of 1 was R2. Now in one's loop I'm increasing R2 by 1, and then after doing this I subtract 1 from the R1. R1 is holding the number of bits to rotate, 32 bits. Now 1 bit is rotated already. Now 32 minus 1, it will become 31, and then BNE, as long as the 0 flag is not 0 set, you just go back to loop 0. Loop 0 is here, loop 0 comes here, and again it will rotate it for one more time, and the next time obviously what goes to the carry flag is 0, because in this number, the number here when you are rotating it for the second time, what goes to the carry flag, when you are rotating it for the first, what goes to the carry flag is 0. This 1 is already shifted, and R2 register is incremented. Now what goes to the carry flag is 0. So what goes to the carry flag is 0. Now BHI, now since carry flag is not high, it will not go to ones, instead it will come to this and increment R3 by 1, and then we have branch to loop, unconditional branch to loop 1. It comes here, and since we have performed 2 times rotate right, now this R1 is again decremented by 1, and this process is repeated. Now the moment R1 becomes 1, 1 minus 1, 0, so the 0 flag is set, it will come out of loop 0, and then R7 is decremented by 1. R7 was initially 2. Now one word, we counted the number of zeros and ones in one word, and now we got to count the number of zeros and ones in the second word. We are decrementing it by 1, and again subbase is there. If 0 flag is not set, again go back to loop where it comes here, and again put 32 to the register R1, and now R6 was already pointing to the second memory word here because it was post incremented. Now what goes to R0 is this second number goes to R0. Now again keep rotating right the second number also. Whenever 1 goes to the carry flag, it branches to ones. If 0 goes to the carry flag, it comes here only and updates, increments the R2 by 1, R3 by 1. If 1 goes to the carry flag, R2 is incremented by 1, otherwise R3 is incremented by 1, and this is repeated for 32 times. And next time when it comes here, 1 minus 1, it is 0, it will not go back to the loop, it ends here, payback, and the process stops. Hope you understood this program. Let me quickly execute this program and show you. Yeah, here is the program. Let me stop debugging. Save, I'll assemble, build, yeah, and then debug. Yeah, I need the memory window. Let me drag it a little up. Yeah, and here I'll show you this is what the data we have taken, 111 and AA55, AA55. Okay, I'll go to the memory window 1. Okay, now let me start executing, tracing the program from here. We are loading R2 with 0 because it is the counter for ones. Now R2 is already 0, again we are making it as 0. R2 is 0. R3 is also made as 0. Now R7 is assigned with 2 because I got to count the number of zeros and ones present inside 2 consecutive memory words. Now R7 is made as 2, and then I'm loading the starting address of the value to register R6. So R6 is 40. Now if I go to the address 40, you can observe here first number and second number, it's stored here. Now I'm loading R1 with the register, R1 register with 32, that is 32 in XI is 20, and now I'm loading the first number to register R0. R6 is pointing here, R6 is pointing here. Now what goes to the register R0 is the first number, that is 111. R0 is loaded with 111. Now R6 is incremented and it is pointing to the second number in the memory location. Next, what we are doing is we are rotating right. We are rotating right the content of register R0 by 1 bit. Now this is hexadecimal equivalent, but you have to take the binary equivalent of it. This is the binary equivalent. Now this 1 will go to the carry flag, and the same 1 also goes to this position, and the value which you should get in R0 is 888. Observe now. When I do this, and you got to observe the carry flag also. Carry flag is right now 0. The moment I rotate right on this, the carry flag will become 1. And observe R0, it will become 888. See, R0 is 888 and the carry flag is 1. Now next, what we are checking the condition, branch on I. If the carry flag is I, yes, carry flag is I now. Now it should go to the loop once. Comes here, and R2 is incremented by 1. That means there is 1 when 1 count is incremented by 1. Next, because we encountered 1 digital bit 1. Next, subtract, because we finished with 1 rotation. Now I have to do this for 31 more times. R2 is subtracted by 1. So R2 is subtracted by 1 and it is 1F. That is 31. And now B and E, it's not same. It will go to loop 0 again. Loop 0. Now rotate it for the second time. Now when you are rotating it for the second time, what goes to the carry flag is 0. What goes first time, this 1 went to the carry flag. Now this time the 0 will go to the carry flag, and the same 0 goes back to the MSB position. And what you should get in the register R 0 is 444. Observe, this will be 444, and carry flag, which is 1, will change to 0 now. So carry flag is 0 and this is 444. Now the condition what we are checking is BHI. See the arrow here, BHI. It is BHI. So since the condition is false, it will not go to ones. It will add these two. It will increase R3 by 1. And branch to loop 1. Then subtract again 1 more bit, and then BNE to loop 0. Repeat this for how many times? 32 times. Now let me do it 32 times. Okay, just keep observing the register R1. The moment it becomes 0, I'll stop it. B, this is now A, 9, 8, 6, 5, 4, 3. Let me go a little slower now. 2, 1. Yeah, branch to loop. Yeah. Now it will subtract. Now it will not go back to the loop 0. It comes here. Now we have counted the number of ones and number of zeros in the first word. How many ones are there? 8 ones are there, and there are how many? 24 zeros. 24 in XI is 18, and this is 8 ones, which I already showed you in the PPT too. Here, 8 ones and 24 zeros. 24 in XI is nothing but 18. Now I'm subtracting. One word is done. Subtracting 1 from R7. 2 minus 1, it is 1. And again loop back. Now R1 is again reloaded with 32. Now what goes to R0 is the second number, AA55, AA55, and again rotate right. So branch on I. Now 1 it is, increment. So this R2 gets incremented. From 8 it continues. 9. Let me run it at once and stop. You can observe. See how many ones are there? Hexadecimal 18. That is 24 ones are there and 40 zeros are there. 40 in hexadecimal is 28 and 24 in hexadecimal is 18. This is what I was showing you people here. So 24 ones, that is nothing but 18, and 40 zeros, that is nothing but 18 and 28. Remember this, 18 and 28. So that is the program. OP people understood this program, and this is an easy program. Only thing is two important things here, using ROR and BHI instruction. What BHI does, BHI checks whether the carry flag is I. If the carry flag is I, it branches to ones. Otherwise, it branches to ones and in increment R2. If the carry flag is not 1, then I, then it increments the R3. Hope you understood this program. If you have any queries, you can mail to me. Thank you.